Hello and welcome to day 12. Day 12 for me, not for you, because it is the 17th of December. I'm 5 days behind, but yesterday I was 8 days behind. Well, I'm 5 days behind. So let's catch up. Let's work on cranking this out. Day 12. Okay, so we've got here day 12, Advent of Code. We've got actions. North means to move north by the given value. South means to move south by the given value. East means to E means to move east by the given value. W means to move west by the given value. L means to turn left the given number of degrees. Okay, so now we've got degrees. We've got like a rotation thing going on. R means to turn right the given number of degrees. F means to move forward by the given value in the direction the ship is currently facing. So we're going to have to keep track of rotation in here. Yeah, we're going to have to keep track of rotation and our current coordinates. So we're probably going to do like an X, Y, and then have a rotation value, and then turn based on that. So here's our example. And we'll use this as our example for when we're building the script here for part 1. These instructions would be handled as follows. F10 would move the ship 10 units east. Okay, because we're starting off facing east is what this says here. So only the L and R actions change the direction the ship is facing. Turning left, turning right. And if we're facing east, okay, so if we're facing east, and we turn left, we're going to go up. And if we turn right, we're going to go down. We're going to be facing down. So we're facing east, and we turn left, which means we're now facing north. If we're facing east and we turn right, we're now facing south. Okay, makes sense. Okay. At the end of these instructions, the ship's Manhattan distance, some of the absolute values of its east-west position and its north-south position, from its starting position is 17 plus 8 is 25. Okay, so let's take these and we're going to put these into our input right here. Let's get rid of that. There we go. Okay, and we've got line data that is broken by a single line. Okay, and now we're going to have to code in basically all of these rules, right? I said we have an X and a Y position, which is going to be 0 and 0. We're going to start at the origin, and then we can calculate the distance away that we end up. So ultimately, we'll return the absolute value of X plus the absolute value of Y. Okay, so those are going to be where we end up. Right now, we're not doing anything, so we end up with a value of 0. Okay, so we also have something like rotation, which is going to be 0. So we're facing east and we're at 0 degrees. So now we're going to rotate left or right, and I'm assuming that these are going to be in orders of magnitude of 90. Hopefully they're in orders of magnitude of 90. Okay, so now we're going to go through the data. For line in data, we've got an action, and we have a set of units. So action is going to be the very first letter in the line, right? It's going to be F, N, F, R, F, right? And then we've got our units, which is going to be the integer of line 1 all the way to the end. So the character following the action all the way through the end. Okay, so next, if action is F, then, and I'm starting with F because I want to basically determine what the true action is going to be. We know if our rotation is 0, so if rotation is 0, then our action is actually just going to be moving east, right? Our action is going to be E, and our rotation is, yep, if our rotation is 90, then our action is going to be north. Rotation is 180, and our action is going to be west, back the other direction, 270. Then our action is going to be south, right? And this will tell us where we're supposed to move for the next part, right? Which is going to be if action is, so we're going to do the rotations first. So if action is left, we're going to say rotation plus equals units. So we can have essentially, it will keep rotating us. But we need to add in a check here, right? Because we might end up with lots and lots of positive units. And so we don't want to go past 360. So we always need to take the modulus of 360 here. So if, so this will actually be, will equal rotation plus units modulo 360, right? Is right. Then we're going to say rotation equals rotation minus units. Right? So if our rotation is going to be ends up being less than 0, we want it to in fact be more than 0, right? We want it to be 0 or greater, so we're just going to add 360 to it. Okay. If action is north, then we're going to say y plus equals units. If action is south, we're going to say y minus equals units. East, this is going to be x plus equals units. X minus equals units. And we can basically assume that action is not going to equal forward, because we should have changed it up here, right? So if it changed to something else by the time we get down to the bottom, we know that we've actually done something wrong. So let's just clean, and we'll leave those broken out there. Just sort of groupings there. We can put those back together. Okay, perfect. So if we run this here, we get 25, and the correct answer is 25. Okay, prepare for the brightness. Bam. Blinding. Blinded by the light. Yep, okay. So we've got our input here. Let's test this out. We get 441. So let's submit this. Bam. 441 is the correct answer. So we will continue on to part 2. Okay. Before you can give the destination to the captain, you realize that the actual action meanings were printed on the back of the instructions the whole time. Yay, so we just didn't read the instructions. Almost all of the actions indicate how to move a waypoint, which is relative to the ship's position. So there's another point that we're going to be moving. Okay, so action N means to move the waypoint north by the given value. Action S means to move the waypoint south by the given value. Moves the waypoint east, west. Action L means to rotate the waypoint around the ship, left clockwise to the given number of degrees. Action R means to rotate it right. the given number of degrees. Action F means to move forward to the waypoint a number of times equal to the given value. Okay, so action F has in fact changed. So we have the so we're going to have our position, and we're going to have the waypoint, and we need to move the F. So F means to move forward to the waypoint a number of times equal to the given value, so a number of units. The waypoint starts 10 units east and 1 unit north. So we're going to have like a waypoint X that is 10 and a waypoint Y that is 1. The ship, the point is relative to the ship. That is, if the ship moves, the waypoint moves with it. Okay, so if the ship moves, so when the ship moves here, then the waypoint moves with it. Okay. So same instructions as before. So let's just back up and use these instructions here. Okay, and we should end up with 286 as opposed to 25. That's pretty different. I mean, it's different. Yeah. Moves the ship to the waypoint. Okay, so we're actually moving to move forward to the waypoint a number of times equal to the given value. Okay, so we're moving towards the waypoint 10 times. Okay, so this is going to be a little bit different, obviously, because the F is now we're now moving to the we're actually moving to the waypoint, and then the waypoint moves away from us. So once again, we're going to have x, y equals 0, 0. We're now going to have a waypoint x and a waypoint y, which are going to be 10 and 1 because it starts off 10 units east of us and 1 unit north. Okay, if our action is going to be... Oh, wait. I'm getting ahead of myself. For line in data, action is the very first character, and units is going to be the integer of line 1 to the end. Okay. If action is F, let's scroll down just a little bit. If action is F, then we're going to have x plus equals the waypoint, right? So we're moving to the waypoint, and we're going to move towards the waypoint units number of times, right? So our current location will move to the waypoint unit number of times, and y is going to be, is going to be the same thing, where we have waypoint y times units as well. Okay. So if our action is north, then the waypoint y plus equals units. Okay, so these are actually going to be mostly the same here. Okay, except that this is going to be waypoint y, waypoint y, waypoint x, action equals left versus right. Whoops. If the action equals left, then we're rotating the, let's just double check the rules here. We are rotating the waypoint around the ship left, counterclockwise, to the given number of degrees. Perfect. Okay. So this would mean that while we have units, and we're going to subtract units by 90, okay, so that's the given number of degrees that we are rotating, and we are going to have waypoint x and waypoint y are now going to turn into negative waypoint y and waypoint x. They're essentially going to swap places, but with a negative. And we'll have something similar here. Action equals right. This means that while we have units, right, and we'll have waypoint x and waypoint y are going to equal waypoint y and negative waypoint x. So essentially, we're rotating. We're alternating. We're flipping the x and y coordinates for that particular for the waypoint, but we're flipping it as a negative. And if we rotate left, if we're rotating left, then x will become the negative of y, and y will simply become x. Whereas if we're rotating right, am I doing this right? Right. Then we have waypoint x turns into waypoint y, but waypoint y becomes the negative of x. I think I'm doing that right. Okay. And then, of course, we need to return abs x plus abs y, assuming that we're still doing the Manhattan distance here. Yep, still the Manhattan distance. Okay. Let's try this again. 286. The correct answer is 286. Okay, so that is promising. That that is in fact the correct that we've done this correctly. Although it was kind of a limited example. Okay, so 441 was our first answer. 40,014, is that our second answer? There it is. Okay, there we go. Well, that's all for this video. I hope it was helpful. I hope you enjoyed it. This particular part felt like it was just writing a bunch of rules. I don't know if maybe I'm not fully understanding some of the elegance to the particular problem, but it felt like I was just writing up a bunch of rules and didn't feel like I was trying to come up with any type of clever solution. The most interesting part, I think, was here with the waypoint. That was certainly interesting with the reversal of the x and the y, but I don't know. I just kind of want there to be a little bit more math, you know. So with that, we will get into day 13 next time. This has been day 12. If you have any questions, comments, concerns, throw them below the video in the comments. Don't forget to like and subscribe to the channel. But yeah, until next time, I'll just see you in the next video.